Good morning, students. Today we will see what is a prism, how refraction of light takes place when it passes through prism, and also we will see certain quantities like the angle of minimum deviation, and we will also try to see the relationship between angle of deviation and angle of incidence, angle of the prism, etc. So, what is a prism? A refracting medium bounded by two mutually inclined planes is called a prism. So here you can see the picture of a prism and light is passing through that. When it is white light, it gets separated to different colors, its component colors when it passes through the prism. So here it is a refracting medium bounded by two mutually inclined planes. So you
Teacher,
have two mutually inclined planes here.
Fahima is waiting.
Yeah, I'm admitting them. So these are the two mutually inclined planes. Here you can see the two mutually inclined planes, and then these two are the two mutually inclined planes. And then this is a different medium from the surrounding. If this is air, what we have here is glass. So a refracting medium bounded by two mutually inclined planes is called a prism. Now, there are different types of prism. I will refer to two of them. One with six rectangular planes is called a rectangular prism, as you can see here. So this is a rectangular prism and it has six rectangular planes. But we will be learning in this chapter about the other prism which has three rectangular planes and two triangular planes, as you can see here. So we will be discussing here about a prism having three rectangular planes and two triangular planes. Now, few terms related to different parts of a prism. The angle between the refracting surfaces is called the angle of the prism. So, which are the two refracting surfaces? This one and this one. So, this angle is called the angle of the prism, or here, this is the angle of the prism. Mostly, the angle of the prism is represented by letter A. And we have mostly equilateral prism. So can you guess what will be the angle of the prism?
60.
60-degree, because each angle for a equilateral triangle is 60-degree. So the angle of the prism mostly will be 60. In problems, it will be given mostly. If it is not mentioned, you can consider it as 60-degree. Then the line along which the refracting surfaces meet is called the edge of the prism. So this line along which these two refracting surfaces meet is called the edge. So this is the edge of the prism. And the surface opposite to the edge is called the base of the prism. So what is here on the ground is called the base. It's opposite to the edge. So the surface which is opposite to the edge is called the base. Now, any portion of the prism perpendicular to the edge is called the principal section of the prism. So if you consider a portion which is perpendicular to the edge, it is like this. So if a prism is cut, so what you will get is a triangle. So what is the principal section of this prism? A triangle. Can you tell me what will be the principal section of this prism?
Square.
Yeah, it can be a square or a rectangle. It depends upon these two lengths. So it can be either a square or a rectangle. So that's all about prism. I think you are clear what is meant by a prism. You may learn this definition. It may come for 1 mark. What is a prism? It's a refracting medium bounded by two mutually inclined planes. Now let us see what happens when light passes through a prism. So what happens when light passes through a prism? it gets refracted because prism is made of glass. Now, when a prism is kept in air, when light passes through the prism, it gets refracted because it is entering another medium. Here you can see a diagram. What you can see here as PQR is the principal section of a prism that is in the that is a triangle, and here from E, a light ray is incident on the surface PQ. So here EF is the incident ray. Now N1N is the normal to the surface PQ. Here PQ is a little inclined. So N1N is also inclined. The angle between N1N and PQ is 90 degree. Here this angle will be 90 degree. This angle will be 90 degree. This angle will be 90 and this angle will be 90. So N1N is the normal drawn to PQ. Now, if I1 is the incident ray and when it enters the denser medium, R1 is the refracted angle. Angle R1 is the angle of refraction because the ray bends towards the normal when it enters the denser medium. So the ray of light will travel from F to G when it enters the prism. And at G, it again gets refracted when it comes out of the prism. So here it is traveling from a denser medium to rarer medium. Again, it gets refracted at the surface PR, and N to N is the normal drawn at the surface PR. So when it is entering a rarer medium, what happens? It will bend away from the normal. So it is bending away from N to N. See, it gets deviated towards the base. So the path of the light ray is E, F, G, H. Is it clear to you?
Yes.
And we can call EF as the incident ray. FG we can call the refracted ray, and GH is the light ray coming out of the prism. So it is called the emergent ray. And angle I1 is called the incident angle. R1 is the refracted angle. R2 is the second refracted angle. And I2 is called the emergent angle because it is coming out. So this is called the emergent ray and I2 is called the emergent angle. Suppose there was no prism. So what will happen? The light ray from E will pass on straight without any deviation through the line EFO, right? If there were no prism, it will go on straight. Also, when you are looking from here, we will feel that the light that reached H, the light coming from this prism, will be coming from the point O. If nothing was here, we feel like if you are looking from this end, we will feel that it is coming straight from this point. So this is the direction of the incident ray and this is the direction of the emergent ray. And the angle between these two rays is called the angle of deviation. In most books, it will be represented by the letter D, but in your book, it is represented by delta. It can be represented either by D or delta. So here, delta represents the angle of deviation. Can you tell me what is the angle of deviation?
Delta.
Delta, what is it in a sentence? It is the angle between the incident ray and the emergent ray. The angle between the incident ray and the emergent ray is called the angle of deviation. Is that clear to you? When a ray of light is incident on a prism and after refraction emerges out, the incident ray and the emergent ray are not parallel to each other. See, incident ray is in this direction,
Teacher,
emergent ray in this direction. Yes?
So can you show this figure on the board because it's
Yeah,
so confusing?
I will show that on the board how to draw, because I have to derive an equation connecting the angle of deviation and angle of incidence and the angle of the prism. So I will draw that on the board and show you. Okay. Only then you will clearly understand how you can draw this figure. You will have to draw this figure while deriving the equation. Okay. So let me just introduce angle of minimum deviation, then we will go forward with the derivation of equations. Is that okay, Mohammad Zaman? Is that
Yes, teacher.
okay? Okay, so we will also see what is angle of minimum deviation. So angle of minimum deviation, which is represented by delta m. You now know what is angle of deviation. It's the angle between the emergent ray and the incident ray, right? The angle of deviation of ray of light in a prism depends on the angle of incidence, which means if we change the angle of incidence, the angle of deviation also changes. Here there is a graph that shows the relation between angle of incidence I and the angle of deviation delta. Here you can see this is the shape of the graph. So when you increase the angle of incidence, what happens? As the angle of incidence increases, in the beginning, the angle of deviation decreases. See, as the angle of incidence increases, the angle of deviation is decreasing. But for a particular instance, say I, the angle of deviation is a minimum, which is represented by delta n. Now, when you increase again the angle of incidence, what happens? The angle of deviation will increase. So there is a particular angle of incidence for which the angle of deviation is minimum. Now, if you increase the angle of incidence or decrease the angle of incidence, what happens? The angle of deviation will increase. See, when you increase the angle of incidence, then the angle of deviation increase. When you decrease from this point, then also the angle of deviation increases. So this point where the angle of deviation is minimum, this value is called the angle of minimum deviation. It's represented by delta m. The particularity is that at the angle of minimum deviation, I1 will be equal to I2, which means the angle of incidence will be equal to angle of emergence. The angle at which it is incident and the angle at which the light ray emerge will become equal. Similarly, the two refracting angles will be same. This happens only at the angle of minimum deviation. They may be different at other values of the deviation. Is that clear what is angle of minimum deviation?
So can you repeat that part? Like you said, the angle of, I mean, at delta m, the angle of deviation and angle of incidence will be same.
Yeah, at the angle of minimum deviation, I will show here. This is the angle of incidence I1, right? This is the
Yes.
angle of emergence I2. These two values will be same, equal. I1 will
With
be
rest. Okay.
I2 when the deviation is minimum. Also, R1 will be equal to R2 when the angle of deviation is minimum. So now I will show you on whiteboard few relations. So to derive each of these relations, I will have to draw the figure on whiteboard. So I'm stopping the sharing of video, and I will let us see the whiteboard. Can you see the whiteboard clearly now?
Yes, teacher, we can.
So let me show you the angle of deviation on the whiteboard. So here we have to show that the angle of deviation delta is equal to I1 plus I2 minus A. This is a relation which you have to memorize also for solving equations. So we saw that if you have a prism PQR, and if a ray of light is incident on it, suppose the ray of light is coming from E and it is incident on the surface at a point F, then after suppose N1N be a normal drawn at the surface. Okay. And then after refraction, what happens? Suppose I1 is the angle of incidence. When it is entering the denser media, it will bend towards the normal. So it will bend towards the normal. So R2 will be less, R1 will be less than I1. Is that clear to you? The light ray which is incident gets deviated little bit. That is, it bends towards the normal. And at this surface, it is incident at a point EFG. Okay, it will be incident at this point. Now, suppose at this point, the normal is N to N. I have drawn this point as N. N to N is the normal drawn to the surface PR. Okay. Now here at point G, what happens? It is going to a rarer medium. So it should bend away from the normal. If it goes straight, it will bend away from the normal. So what happens? It gets deviated down. That is why the light ray bends towards the base, nearer to the base when it comes out. So here EFGH, it reaches a point H. Now here it is incident here inside the medium. I will mark this angle as R2 and this emergent angle as I2. So this is the incident ray, this is the refracted ray, this is the emergent ray. Now, in the absence of the prism, if the light ray is going on straight, it would have gone in this direction. It would have gone like that. If there were no prism, it would have traveled along a straight line. Now here,
It won't refract
yes,
if it
yes,
wasn't a prism.
what? If there
If
were
it wasn't
no, it would have gone like this, right?
like a refracted ray, it's not refracted.
It will not be refracted if there were no prism.
Okay, okay, got it.
There were no prism, light ray always travels in a straight line. So this is the direction of the incident ray. Now, when you look from here, when you are looking from here, you feel that light is coming from a point there. So this is the emergent ray. So when you look at the emergent ray, you feel as if the light ray is coming from this point. So this point where the incident rays direction meet with the emergent rays direction, I am marking it as O. Okay. So this is the angle between the incident ray and the emergent ray. So let me mark it as the angle of deviation delta. Is this figure clear to you?
Yes, clear.
Okay. Now we have to prove that delta is equal to I1 plus I2 minus A. What is A? A is this one, angle of the prism, A. Angle of the prism is A. Now, in order to prove that, consider this angle, this small angle. Here, this angle. See, EO is this line. N1N is this line. right? This angle is I1. So what will be this angle? I1 itself, right? EO, N1N. So if this angle is I1, this total angle should be I1. But here we have a part of that broken like this and R1. So what will be this angle? This whole
I1
angle
minus
is
R1.
I1. But a part of it is R1. So what will be the small angle?
I1 minus R1.
I1 minus R1. So I can mark this angle as I1 minus R1. Right? I can mark this angle as I1 minus R1 because these are two crossing lines. So this angle and this total angle should be same. But part of that is R1. So I can mark this as I1 minus R1. By the same explanation, here you have OH, this line, and N to N, N to N. And this angle between N to N and OH, here is I2. So what will be this total angle? This also will be at I2. But instead we have a refracted ray coming here and this angle is R2. So what will be this angle? What will be this angle?
I2 minus R2.
I2 minus R2. I2 minus R2. Okay, so this was just to explain that. Understood, this is I1 minus R1 and this is I2 minus R2. Now, okay. Here, if we have any triangle, suppose you have any triangle, what do you call this? We draw any triangle. You have a triangle and you have this angle. What do you call this?
External angle.
External angle. Suppose this is x, this is y, this is z. X is equal to
Y plus Z.
y plus z. So you know that, right? The external angle is the sum of two internal angles. You know that. Now, I am going to apply that here. Consider triangle OFG. Okay, we are considering OFG, triangle OFG. From that, we can tell delta is the external angle and the internal angles are I1 minus R1 and I2 minus R2. So I can write delta is equal to I1 minus R1 plus I2 minus R2. Is that clear?
Yes, teacher, clear.
Yeah. Okay. So I1 plus I2, I am writing together I1 plus I2. Then what is remaining? Minus R1 and minus R2, right? So I can write this as I1 plus I2 minus, I am taking outside, minus of R1 plus R2. I can write like this, right? Now compare with this. We just have to show that R1 plus R2 is A, then we will get this solution or we will get this equation. So our idea now is to make A equal to R1 plus R2. Let us see how we can prove that. For that, consider the quadrilateral PFNG. So consider quadrilateral P F and G, this quadrilateral, P, F, and G. Okay. So what is the total angle inside a quadrilateral? Sum of all the angles inside a quadrilateral.
180.
No.
Oh, it is 360.
360. The sum of all angles inside a triangle is 180.
Yeah, 180.
Inside a quadrilateral, 90, 90, 90, 90. So it will be 360, right? So let us
Yes.
write that. This one of the angle is A plus. What is this angle PFN? PFN is?
I1.
No.
Which one? Which one? Which one? Can you say again?
PFN. PFN. N1
Okay.
and P2.
R1 plus.
Yeah. So PFN will be?
I1 minus R1.
No. I am asking angle PFN. PFN.
That's
PQ and
confusing.
N1 and are perpendicular to each other. Let me write only those two lines. This is N1, this is N, and you have PQ. P.
90, 90, 90. Got it now. The drawing was, I was confusing.
And this point is marked F. So what is the angle between P
90, 90,
and
90.
N?
Like the drawing was confusing. That's why I didn't understand.
Yeah, the drawing, there is other lines in between, that's all.
Yeah,
Okay,
yeah.
PQ, N1N, and F is the
Perpendicular
point.
each other.
So PFN, what is PFN? 90.
90 degree.
Got it?
Yes, got it.
So this, I can write one angle is A, another angle is 90 degree, because we are considering the quadrilateral PFNGP. So here, this angle, and what about this angle? Let me express this angle as theta. We
It's
don't.
90, right?
This angle is
Oh,
theta.
no, no. Theta. Sorry.
Plus theta plus, what will be this angle? Angle between
Same
angle
90.
GN. PGN will be 90 as
90.
well. Why? You have
For same,
1
it's
here.
perpendicular, right?
Yeah. And N to N is normal to it. And this point is G. So what is angle PGN? 90 degree. So here we have this angle also equal to 90 degree. This is the sum of all the angles inside a quadrilateral, which is equal to 360 degree. Okay. So if you take 90 plus 90, that will be 180. When it goes to the other side, minus 180. So what is angle A plus theta will be equal to
180.
180 degree. So you have angle A plus theta equal to 180 degree. Let me denote this expression as equation 1, this as equation 2. Now, let me consider the triangle FGN. Consider the triangle FGN, this triangle FGN. What is the sum of the angles inside a triangle?
180.
180. So you have from triangle FGN, R1 plus R2 plus theta is equal to 180 degree. Now let this be equation number 3. Now look at equation number 2 and equation number 3. Compare equation number 2 and equation number 3. Here we
A
have
equal to R1 plus R2.
here we have theta, here we have 180. So comparing equation 1 and 2, we can write A is
2 and 3.
result. Equation 2 and 3, we have A is equal to R1 plus R2. Therefore, this equation 1 will become I1 plus I2 minus A. Therefore, equation 1 will become what? Delta is equal to I1 plus I2. Sorry, I1 plus I2 minus A. We got the expression. Is this clear to you?
Yes, teacher, clear.
Okay. So we are deriving this expression considering the refraction of light through a prism. What we did was we first consider the triangle OFG. 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 So here, this angle is equal to I1 because it is opposite to this I1. This will be I1. So a part of it will be I1 minus R1. Similarly, this side, it will be I2 minus R2. Then looking into this triangle, we know delta is the exterior angle, which will be the sum of the two interior angles. So delta is I1 minus R1 plus I2 minus R2, and we rearrange that equation to get equation 1. Now, we consider the quadrilateral PFNG, PFNG, PFNG. And the sum of all the angles in a quadrilateral is 360 degree. So, angle A plus PQ and N1N is they are perpendicular to each other. They meet at F. So PFN will be 90 degree plus theta. Similarly, PGN will be 90 degree. So sum of them is 360. 90 and 90, if we take to other side, we will get A plus theta as 180 degree. Then we consider the triangle FGN. So sum of the angles inside a triangle is 180. So R1 plus R2 plus theta is 180 degree. Then we compared these two equations and we got A is equal to R1 plus R2. So when we substitute for A in equation 1, we will get delta is equal to I1 plus I2 minus A. Is this clear to you? Is this
Yes,
clear
teacher.
to you?
Yes, clear.
Okay. So this is one of the equation which you have to remember. Plus remember this one. This is also true in all cases. A will be equal to R1 plus R2 always. So we have this relation which you have to memorize. Plus you have to memorize the relation that A angle of the prism is equal to R1 plus R2. Now we have to prove another equation which you will have to memorize, which is a relation between the refractive index of the material of the prism and the angle of minimum deviation. Remember, when delta is equal to delta m, when the deviation is minimum, angle of incidence is equal to angle of emergence, and two refracting angles will be equal. This is the condition when the deviation is minimum. We have seen that condition. Now with these conditions, let us find a relation between refractive index of the medium mu and the angle of minimum deviation. So we are going to find a relation between the refractive index and the angle of minimum deviation. And we know this equation, and this condition. Okay. So do you know what is generalized Snell's law? What is generalized Snell's law? Who can tell me the relation?
I1 into sine I. That one?
Mu1 into sine
Okay,
theta 1.
sine theta 1 equal to mu 2 sine theta 2.
Sine theta 2. So this is generalized Snell's law, right? Now let us apply that at this point, this refraction. The incident ray gets refracted here, right? This refraction. So what is the refractive index here? Mu1. Suppose this is air and this is glass because this is prism. So in air, the refractive index is equal to 1.
1.
Refractive index of air is 1, which means mu1 is equal to 1. And glass, let the